Since the beginning of time, man has searched for different and more exotic materials for use with the pigments used in their art. From simple cave paintings many tens of thousands of years ago to the perfection seen from masters during the Renaissance, none have ever been as interesting as our next artifact. Known as Han Purple, it has been found on relics dating back 3,000 years. Used in wall paintings, on the terracotta warriors, ceramics, metalwares, and jewelry, the pigment found its way into many ancient Chinese art, and amazingly, this intriguing pigment is a technological wonder. It was such an enigma made through such a complex process using many different materials in precise proportions, and then heating the mixtures to incredible temperatures. Researchers at the British Museum have discovered that when the pigment is exposed to an LED light source, Han Purple pigment will emit a powerful ray of light in near-infrared. According to their study, published in the journal Analytical and Bioanalytical Chemistry, the Han Purple pigments show up with startling clarity when under the right conditions, meaning that even faint traces of the color which are invisible to the naked eye can be seen with infrared sensors. A complex pigment clearly developed for complex applications. Unlike natural dyes found within antiquity, which are organic compounds, Han Purple is a synthetic pigment made from inorganic materials. Scientist Elizabeth Fitzhugh, a conservator at the Smithsonian, was the first to identify the complex synthetic compound that makes up Han Purple, including a barium copper silicate. How these ancient people acquired such knowledge is clearly a question which needs to be answered. And although many people often scoff at ancient alien theories, quantum physicists from Stanford, Los Alamos National Laboratory, and the Institute for Solid-State Physics of Tokyo have reported that when Han Purple is exposed to extreme cold and a high magnetic field, the chemical structure of the pigment enters a new state called the quantum critical point, in which three-dimensional materials loses a dimension. We have shown for the first time that the collective behavior in a bulk three-dimensional material can actually occur in just two dimensions, Ian Fisher, an assistant professor of applied physics at Stanford, said in the Stanford report. The researchers have said that the discovery may help understand the required properties of new materials, including more exotic superconductors. Was this marvelous pigment a gift from somewhere else? We find the evidence to be highly compelling.